Welcome to my YouTube channel, A Brainery of Civil. Today I am going to solve the second assignment of Strength of Materials. Are you ready? Okay, let's start. So the first question is, select wrong options from the following statements. He has given some statements. We need to select wrong option from that. Shear stress in principal plane is non-zero. Obviously, the first statement itself is wrong. And normal stresses in principal plane is always compressive. Shear stress is zero in principal plane. So, we need to know what is a principal plane, what are all the stresses over them. Okay, so I am writing here principal plane. So, it is the plane on which shear stress is zero, is called principal plane. Okay, and the stresses over the principal plane, most of the times it will be compressive stresses. Okay, so the first statement is wrong statement. So the answer is A. Coming to next question. The angle between principal plane and the plane with maximum shear stress in a physical element. So physical element, first of all we take one physical element, a cube. Okay, I am taking one cube. So now if it is a major principal plane, the plane on which stress is maximum, we say it is major principal plane, and perpendicular to this major principal plane there is one more plane. This is the angle between these two is 90 degrees, minor principal plane. With principal plane, there is one more plane called shear stress plane. That shear stress plane will make an angle 45 degrees. This is 45 degrees shear stress plane, that is maximum shear stress plane. So the angle between principal plane and maximum shear stress plane is 45 degrees in physical element. Okay, so whenever we consider one physical element like a cube, so the angle between principal plane and the shear stress plane is 45 degrees. So the answer is answer A. And is there any other angle in which other than 45 degrees between principal plane and the shear stress plane? Yes, it is there. It is there on the Mohr circle. Here 45 degrees means in the Mohr circle the angle between principal plane and the maximum shear stress plane. So I will explain that also here. So if I will draw a Mohr circle, so this is major principal stress sigma 1, this is minor principal stress sigma 2. If I will draw a circle passing through these two, so this is maximum shear stress plane. Okay, and angle between this maximum principal plane and this is 90 degrees. With this is also 90 degrees. Okay, so that is we have drawn a conclusion here, like if theta is the angle in physical element, then 2 theta is the angle in Mohr circle. Okay, answer is A for 2. And a rotation of 2 theta in Mohr circle actually represents, I just explained earlier. So in Mohr circle the angle is 2 theta. In actually it represents theta. Okay, so the angle rotation in physical system. So theta is physical system, 2 theta is Mohr circle, or else theta is in Mohr circle, theta by 2 is in physical system. That is, in Mohr circle the angles are always twice the physical system. So the answer will be B. Okay, and you can see here Mohr circle for hydrostatic stress element is, so hydrostatic stress element means, for example I have drawn a cube. If we place one cube inside water, so that is it will exert equal pressure on all the sides. That is, this is sigma, this is sigma, this is sigma, this is sigma, 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 sigma. As I told in the definition of principal plane, the plane on which shear stress is 0 is called principal plane. Here there is no shear on any plane. So that is, this is one principal plane and this is another principal plane having both are equal magnitude. If I draw a Mohr circle, so generally Mohr circle diameter is difference of major and minor principal stresses. Here there is no difference of major and minor principal stresses. So the difference is 0. 0 means you will get point Mohr circle. Okay, I will explain it again. So this is one principal stress, sigma. 1 is equal to sigma. This is one more principal stress, sigma 2 is equal to sigma. So that there is no difference between. So actually you will get it is a point. Okay, or else you can also draw like center of Mohr circle. Sigma 1 plus sigma 1 plus sigma 2 by 2. Here sigma plus sigma by 2, that is sigma. So that is center of Mohr circle will lie at a distance sigma from origin. This is origin, this is sigma. And radius will be difference of Mohr circle, difference of major and minor principal divided by 2. So there is no difference. So radius is 0. So finally it is a point Mohr circle. The most important question, this one, for a hydrostatic state. So thus Mohr circle is a point Mohr circle. Okay. So the question of the answer for this question is option C. And now next question. The pure shear stress and maximum shear stress in a physical system coincides when? For example, first I am taking pure shear case. So this element is subjected to tau. I will calculate maximum principal stress and minimum principal stress. Sigma 1 or sigma 2 is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 whole square plus tau xy square. So here in this pure shear element there is no sigma x, sigma y. So you will get sigma 1 is equal to plus tau, sigma 2 is equal to minus tau. Okay. So these are all the stresses. Major and minor principal stresses are same of different magnitude. This will coincides with what? With what means? Let's go with option number 1. So option number 1, principal stresses both are compressive. So this is compressive. So this is sigma x is equal to sigma. I am taking in terms of tau. Let it be tau. Sigma y is equal to tau. In this one, I will calculate sigma 1 or sigma 2 is equal to tau plus tau by 2 plus or minus tau minus tau by 2 whole square plus 0 square. That is, there is no shear on the first case. So it will become tau plus tau by 2 will become tau and sigma 2 also will become tau. Okay. So here both the principal stresses are same. Actually, there is no shear stress on this element. When there is no shear stress on the element, these stresses will itself become the principal stresses. Okay. So that is this case, option A is not coincides with given option. And you can come to option C, option B. So all are tensile, all the principal stresses are tensile. Here sigma 1 and sigma 2 will become sigma itself or tau. I am taking a magnitude tau. So tau itself. This also will not coincides with the option, given option, and I am taking option C. Option C means principal stresses are equal in opposite direction. So this is equal but in opposite direction. So here in terms of tau I am taking. So sigma 1 will become tau, sigma 2 will become minus tau. So you can observe here. These are coincides, right? In which system these are getting coincide? That's what he has asked. Option number C, the most important logic question. Okay, maximum shear stress element will coincides with an element which is having equal principal stresses of equal opposite directions. Okay. Okay, unequal principal stresses will be, so option number D is also wrong. Clear? So this is answer C for the question. And next question, sixth question. For a body under hydrostatic stress, the magnitude of maximum shear stress. For example, I have taken an element. What is the magnitude of maximum shear stress? Hydrostatic stress, I am taking it is sigma h. So maximum shear stress means tau max is equal to major principal stress minus minor principal stress, right? Major principal stress. So hydrostatic stress means all sides are equal, sigma h, sigma h, sigma h. Hydrostatic stress means it is taking, hydrostatic stress means it is acting from all the sides. Okay, he has given it is sigma h. Okay, so it will not, sigma h means it is acting only in vertical, horizontal direction, not in vertical direction. So here sigma 1 is equal to sigma h, sigma 2 is equal to 0. So maximum shear stress will be sigma 1 minus sigma 2 by 2, that is sigma h minus sigma 0 by 2. You will get it is sigma h by 2. So the answer will be option B. Clear? And now for question number 7, he has given directly the values. Sigma x is equal to minus 30, sigma y is equal to plus 30, tau xy is equal to 15. The magnitude of maximum and minimum principal, directly formula, sigma 1 or sigma 2 is equal to sigma x plus sigma y by 2 plus or minus sigma x minus sigma y by 2 whole square plus tau xy whole square. डायरेक्टली वो वैल्यूज इस फार्मूला में डालो, आपका आंसर आएगा लाइक सिग्मा 1 और सिग्मा 2 इज इक्वल टू प्लस और माइनस 33.54 MPa. So option D is the answer. Clear? And now, so this is also same question, the maximum and minimum absolute values of principal stresses. He has given sigma 1 is equal to, see generally we will take positive for tensile stress and negative for compressive stress. Okay, so here sigma x is equal to, sigma x is minus 75, it is compressive, so it is minus 75, sigma y it is plus 50, tau xy is here whether you need to take tau xy as plus 10 or minus 10, whatever you take, because of square you will get the same value, but for this it is a coordinate system. If it is the direction of shear stress, I will write with another ink. So this is, if it is the direction of shear stress, this is in the first quadrant and this is in the third quadrant. So first quadrant both are positive, third quadrant both are negative, so tau will become positive value. Okay, here it is in the second quadrant, in the fourth quadrant, so tau value will become, so it is negative. Okay, so here you need to write tau xy is minus 10. Clear? So now sigma 1 or sigma 2 is equal to sigma x plus sigma y by 2 plus or minus sigma x minus sigma y by 2 whole square plus tau xy square. So if you can substitute in all the values in the formula, so you will get sigma 1 is equal to 50.8, sigma 2 is equal to minus 75.8 MPa. So the option will be B. Okay, he has not given any signs, but he has given the directly values. It's very simple. And coming to ninth question, the number of stress components for a system subjected to plane stress condition. Generally you know stress matrix like sigma x, tau xy, sigma y, tau yx, tau yz, sigma z, tau zy. This is tau xz, tau zx, tau yz, tau zy. This is a stress tensor for any element sigma z. So he asked this element in plane stress condition. In plane stress condition means no stress in z direction and no stress in z plane. So that is all the components in this are related to z or 0. That is, one is this is 0, this is 0, this is 0, this is 0, this is 0. So the only remaining are sigma x, sigma y, tau xy, tau yx, 0, 0, 0, 0, 0. So in this element, how many elements are there? There are 4, but not answer is not 4. Okay. In the earlier assignment, I explained tau yx is equal to tau xy. Okay, because we proved that tau xy is equal to tau yx by using moment equilibrium principle. So the independent components are sigma x and sigma y. Out of these two, only one, sigma x, sigma y, tau xy. There are only 3 stress components. Answer is D. And now for a state of next question, for the state of plane stress represented by a stress element as question 8. So we have to go for question number 8. Here the values were given. What he is asking in the question number 10, determine maximum stress and angle at which it acting. So in question number 8, what are all the values that we got for the given element? Sigma 1 is equal to 50.8. We got it right. And sigma 2 is equal to minus 75.8. He asked us to calculate maximum shear stress. That is, maximum shear stress is equal to tau max is equal to sigma 1 minus sigma 2 by 2. Sigma 1 is 50.8 minus of 75.8. You will get it is 63.294 MPa. And angle of inclination of shear stress plane. So tan 2 theta tau is equal to minus 1 by 2 tau xy divided by sigma x minus sigma y. This formula you need to remember directly. Minus 1 divided by 2 into minus tau xy is minus 10 and sigma x is minus 75 minus 50. So you will get this is 2 theta tau is equal to minus 80.90. Theta tau will become 40.45 degrees. Okay. So the answer you will get it is option A. Clear? Okay. The most important. And the radius of Mohr circle is equal to which of the following? So simple. I said when I am explaining about Mohr circle, this is sigma 1, this is sigma 2. So from this diagram, if I will draw a circle like this, so radius will become sigma 1 minus sigma 2 by 2. No, we already know sigma 1 minus sigma 2 by 2 is maximum shear stress, that is tau max. That tau max can be represented in the diagram is this one. This is tau max. Clear? So the option is 11th question is it is A. And now last question. So this will be the last question. Which of the following Mohr circle represent condition of pure axial tension? That is, pure axial tension means an element which is subjected to tension sigma. There is only axial tension for the element. Now we need to draw Mohr circle for this. So in this, maximum major principal stress will become sigma and minor principal stress will become 0. Now radius of Mohr circle will become sigma 1 minus sigma 2 by 2, that is sigma by 2. Clear? Radius of Mohr circle will become sigma by 2. So this will become the sigma by 2 and it will become sigma. Major principal stress is sigma, minor principal stress is 0 and radius will become sigma by 2. So the option will become B. Clear? And these are all very important questions in stress of principal plane. Okay. So You can solve all the questions. If you have any doubt, post the comment below, and thank you.